Appendix A2, the metric system, and in this section we're going to be talking about length. So since we're talking about length, the basic measure for length in the metric system is the meter. Now the meter needs a little bit of help, and so we got to throw some prefixes in front of the meter depending on whether we want to measure something larger or smaller. So again, a prefix is something that comes before. So for example, deca, and we use the word decade for 10 years. Deca is the prefix that we would associate with meter, call it a decameter, to indicate 10 meters. And so as we go to larger things, the next largest will be a hectometer, which is 100 meters, and then finally a kilometer, or kilometer some people will say, is 1,000 meters. Likewise, we want to measure things that are smaller than meters, and so on the other side we have deci. So a decimeter is 1/10 of a meter. Centi, and we get the word 1 cent is 1/100th of a dollar, so centimeter is 1/100th of a meter. And finally, millimeter is 1/1000th of a meter. Okay, here I've included just a few things. The meter abbreviation is M, and so when we start talking about length and these prefixes, the DA is the deca part with the meter since we're measuring length. Hecto would be just the H along with the meter since we're measuring length. The kilo is just a K. Deci is just a D. Notice it's similar to deca. The deca has the A, the deci does not. Centi just has a C, and milli just has the M. Okay, so now we will go ahead and do a conversion. And we're going to do it two ways. One way is the more mathematical way, and it's probably a little bit more difficult. Then I'll show you an easy shortcut. What's key to understand here is notice these are all powers of 10. So you're either going to be multiplying or dividing by powers of 10 when you convert from one measure of length to another measure of length in the metric system. And since they're powers of 10, all that really will do is move decimal points, as we'll see in a minute. Let's go ahead and do the math. So let's say we wanted to do 520 millimeters, and we wanted to convert it into meters. Well, since we want to convert it to meters, we would have to multiply, if we did this the mathematical way, multiply it by its conversion factor. Well, since we're converting to meters, I need to have the meters on top, so 1 meter is exactly 1,000 millimeters, as we can see here from our unit measurements. Notice that if you think of this as a fraction, that's over 1. So our units do cancel. These millimeters cancel out, leaving me only meters, and if you do the multiplication, you end up with 520 over 1,000. And since we're going to go ahead and convert this into decimal form, if you do the division, you end up with 0.520. Now what I want you to notice is if we list in the order of the largest unit of measure, starting at kilo, and go all the way down to milli, the smallest unit of measure, so we have kilometer, hectometer, decameter, meter, deci, centi, and milli. If you write it in this order, it's very easy to convert from one size to another. So for example, we know that when we're going to go from millimeters to meters, there's going to be fewer of them because meters are larger than millimeters. And so notice the relationship here between a meter, right here, and a millimeter. Okay, so as I go from the small unit millimeter to meter, I'm moving to the left, which is exactly what happens to the decimal point because I am dividing. As we see here, I'm dividing by powers of 10. So if we take a look at this and you go, okay, this is where I started at millimeter, and I am going to meters, this is where I end. And you ask yourself, what direction and how many places did I move? Well, if I start at millimeter, to go to centimeter is 1, to go to decimeter is 2, And finally, to make it all the way to meter, I've moved 3 places to the left, which is exactly what I want to do to the decimal point. So if I started with 520, the decimal point is implied to be at the end of the number. And based on this chart, I'm saying I got to move 3 left. Well, if I move the decimal point 1, 2, 3 to the left, it would correctly place it as we showed above when we actually did the math. This is a much easier way to do it because this is ultimately just multiplying or dividing by powers of 10. We'll do one more example showing both ways, and then afterwards we will only use the easy method of just moving left or right on the chart. Let's do the math. So we start at kilometers and we want to end at meters. Okay, since I want to end at meters, I want to go ahead and put my conversion factor, and on top, well, there is 1,000 meters in 1 kilometer. My unit measure, the kilometers, will cancel each other out, leaving me just meters, which is what I want. And if I do the multiplication, I get 3,000 meters. Then it makes sense. We're going from a big unit to something that's smaller, so there's going to be more of them. So the answer was 3,000. Now let's do the easier method of using our chart. Well, we started here at kilometer and we're ending here at meters. And so we go, okay, we started, we're moving to the right 1, 2, 3. So 3 places to the right, which means that's what we do to our decimal point. So if we do that, well, if we take a look at where we started, then the decimal point again is implied at the end of the number if you don't see it. And we move that decimal point 3 places to the right, 1, 2, 3, and place it here, we get the correct answer. So again, much easier to memorize this chart, largest unit to smallest unit, and then where do I start, where do I end, just count the direction and the number of places. So let's just do a few more examples, and we won't do the mathematical part, we'll just use this chart since it is mathematical in the sense of reflecting division or multiplication by powers of 10. So this particular problem, we're starting at meters and we want to end at centimeters. So here we go, we start, and this is where we end. So therefore we go 1, 2 to the right. So since the decimal point is implied to be after the 6, I will have to add zeros in order to be able to move the decimal point to the correct location. So just to be clear, 6 meters is 600 centimeters. Well, let's do another one over here. We're going to start at deca, the DA, the decameters, and we're going to kilometers. Okay, so here's where I start, and here is where I end. I'm going left 1, 2 places. So if I started at 12 with the decimal point implied at the end, and I have to go left 2 places, 1, 2, then my final answer, and it's common to lead any decimal with the 0 if there is no number there, 1, 2, and you can put the 0, although that's not necessary. So here would be 12 decameters is equivalent to 12 1/100ths of a kilometer. Another example, we'll start at millimeter and end at meter. So that's where we start. That's where we end. 1, 2, 3 left. So we'll go ahead and take the decimal point, which is at the end of this number, and move it 3 left. 1, 2, 3. And there would be the result. One more example. You can see how easy this is. So we're going to start at hectometers. So here is our starting point. We're going all the way to decimeter right here. So this is where we end. 1, 2, 3 to the right. Since the decimal point is right there, we will need to add 3 more zeros to move it 3 places to the right. Just another quick example, start at meters, end at kilometers. 1, 2, 3 left. So since the decimal point is implied to be after the 6 and we're moving left, you can see that this time we have to add some leading zeros in order to make this move. So since we're going 3 left and it's implied to be there, 1, 2, 3 to the left would be 0.006 kilometers. That concludes this section. This unit also includes material from Appendix A3, which is really the same, except we're just going to take a look at volume and weight instead of just length. So we started with length, which was our meter, which was the baseline. When we talk about volume, we're going to be talking about liters, and we're all familiar with liters. When you buy sodas, typically you buy liters. It's kind of strange when we buy milk, it's often in gallons, so we mix the two systems. And then when we talk about weight, we talk about grams. You know, often our medication is in grams, even though we measure our body weight in pounds. Okay, so what does not change are these prefixes and their meanings. So these are all exactly the same. The only thing that will change is the suffix, if you will, So here is our system of moving decimal points, and notice that the only thing that changed is instead of just having meters in the middle, we have all 3 of the baselines, depending on whether we're measuring length, weight, or volume. So if we wanted to measure length, it would be in millimeters. If we wanted to measure volume, it would be in milliliters. If we wanted to measure weight, it would be in milligrams. Okay, let's just do a few problems. Nothing changes except just obviously the base unit. So if we wanted to go from 3 grams to grams, well, 3 kilograms. So we're starting here at the kilograms, and we're going to end at grams, which is the base unit. And once again, we do the counting in the direction. So 1, 2, 3 to the right is what we're going to do to the decimal point, since this is our situation to start. The decimal point 1, 2, 3 to the right goes there. So it would be 3,000 grams. Another example, let's just do the liters. Well, we start with liters, which is the base unit, so here's where we start. And we're going to milliliters, which is right here, is where we end. Once again, 1, 2, 3 to the right. So the decimal point is implied to be after the 3. We're going to move it 3 to the right. We would then have to add exactly 3 zeros to move it 3 to the right. So 63 liters is 63,000 milliliters. One more. Let's start at decagrams. Deca. So this is where we start. We're going to end at kilograms right here. So this is where we end. So we start and we're moving 1, moving 2 left, which is what we will do to the decimal point. The decimal point is implied to be after the 2, so to move it 2 left, we will have to go ahead and throw in some leading zeros. 1, 2 to the left would place the decimal right there. So there is our equivalency. That ends this section.